Okay, so P3-39, let's see, I jumped ahead, no? Okay, 339 has the consider a shell, and I mentioned earlier is consider it, and then don't bother with it. It's kind of a pain. This lends itself to sheet metal, so we'll go into a metric part, and the sheet metal module is inside of the part. Let's go ahead with our front plane and sketch. And doesn't really matter. We'll go with the lower left corner, up, over, and out, and over and up. And the consideration with this being sheet metal is, do we have enough reach for the fingers or the or die on a press brake to reach in there and make that offset. So height-wise, we are at 35. Width, we're at 45. And depth is 35. And these are all outside dimensions. Double check here. Yeah, all outside dimensions. And height. Let's see. Nope, that one's to the corner. Oh, and then we have 18. So it's pretty snug to get into this geometry, make those last couple of bends. So it may not be practical, or maybe we have to do a little redesign on the tabs. All right, so fillets and rounds are radius of 3. Material is 5. Typically, we would go with a minimum radius thickness of the material so that we don't end up with too tight of a bend. So I'm going to go turn on the sheet metal. Right-clicking on the tabs then and selecting the sheet metal will activate its tab. This can be the base flange, and I'll go ahead and make it mid-plane. And overall depth is 80 millimeters. Okay. Thickness of the material, we have 5. Radius was set to 3. So you can kind of see in the corner it looks a little bit tighter than maybe what we'd like. K-factor is the average of the stresses. So when we're making this bend, we're putting the interior in compression. We're putting the exterior in tension, and in normal piece of material sitting there, the K-factor or the equalization of those stress forces would be right through the middle at 0.5. As we make this bend, it kind of shifts a little bit to the compression side, so 0.3 is a good place to start if the material is going to grow or shrink as we go through this deformation process. And let's see, it went to the inside, so I do need to reverse the direction. That looks a little better. So that makes it even tighter getting into that corner. So yeah, we'll have to see about what we can do with that part. Okay, so that gives us our base flange. The top notch is not really that big of a deal. So same thing that we've been doing, select midpoint, select edge, go to midpoint, place some dimensions. We have a depth of 25. And a width of, well, let's see, that one went to the bottom. Assume 42 places, so we'll go with 40. And the other side is, even if we were machining this, we would have kind of the same limitations of what we could get into. So if we could do those outside 2 bends and then just with a little offset sneak in the middle, we could do the last bend. That might still work. Alright, so features, extrude cut. Link to thickness just says whatever the material thickness is, it's going to match it. And make the cut. Alright, we'll worry about the fillets a little bit later. The notch through the backside then. Set up the sketch. And pretty much on center, 15, 50, and yeah, so we'll go select midpoint, Control select the origin, that can be vertical. Smart dimension is 50 by 12 on our side. And then location wise is 10 off of the bottom. And then that one can extrude cut, also link to thickness. Alright. So then the last notch that goes over that bend, that has a little bit of an issue in that I can make that cut. Actually, I can make that cut all the way through at the depth that they've given, 12 millimeters. Kind of hard to tell. It looks like it's off of the outside, but let's see, 12 millimeters with a 5 millimeter thickness. Let's do this just a little bit different so that we can use some of the sheet metal tools. So sheet metal has the ability to unfold the part. We don't want to mess with the flat pattern just yet. That's a different deal. So if I tell it to unfold, and the bend to unfold will be this one, then that will flatten it out. If I had grabbed all of them, then 1, 2 would have gone with it, and I would have had a complete flat. Didn't really need that, so we're going to go with just the one piece. And let's see, off of the edge then, 5 millimeters, select midpoint, go to midpoint, and then I can make the projected line go collinear, extrude cut, and it's also linked to thickness. And then that we've folded it, or unfolded it, we need to fold it back up. So bends to collect, and that returns it. Alright, so let's see how I did on my number. So 13 millimeter. Alright, so let's change that to 4 and rebuild. So this probably has more or better functionality when we have a circle or some type of more complex geometry going across the bend, but it has the same basic result. Alright, so S, we're into 8 millimeter hole, 4 places. Let's go up to next. Don't think there's a link to thickness in this one, so we'll stay up to next. And positions, since it rotated around. Let's go with a vertical. The distance is off of the leading edge, so 12 millimeters. Off of the backside then, 8 millimeters, 2 places, 12 millimeters, 2 places, and then 10 millimeters off of the edge, 4 places. So toss up between putting the dimension in or setting it to symmetrical. Alright, so this may be a place where if we did need to make a change or there was going to be different sizes, that we could consider using a global variable. So let's go normal 2, S key, and still 8 millimeters, still up to next. We'll set the position, except now they're going to be horizontal. Off of the top is going to be 8 millimeters. And it looks like it's going to get a little into that radius, so that'll be interesting. And then 10 millimeters and 10 millimeters. Okay, so we've talked about global variables before, and we have all of our values set up, so let's go over to Tools, Equations, and I want to set up a global variable for an offset. So sheet metal automatically dimensioned for the thickness. Here's all my available dimensions. So we're going to have a side, let's do lowercase and uppercase offset of 10 millimeters. And what I'm looking for is all of those dimensions that we set at 10 millimeters. Alright, so assuming that I have the right ones, that's kind of the guess here, is they should be the last in the groups. So 10 millimeters, 10 millimeters, set equal, side offset, check, side offset, check, side offset, check, and equals side offset, check. Okay, so what that does, and we could do the same thing for the 8 or the 12 depending. Even if our sizing, that still looks like it's pretty close to the bin. Yeah, 8 millimeters. Alright, so to change the side offsets then, we can go back in, manage the equations, and if I change the side offset from 10 to 5, and then rebuild, it picks all of those locations up and moves them over for me. Okay, so it's just if it was a more complex part, you might have a little more advantage in setting up those variables. Alright, so setting for the fillet, 3 millimeters for the size. We'll go ahead and set the other. And actually there is only the interiors left. So we'll grab those. Don't see anything on the outsides. And that puts us in a good position. Alright, so this is P3-39. And then with sheet metal, well, let's go ahead and do the other part. With sheet metal, we can flatten, and that unsuppresses the pattern. Interesting. So maybe the holes going through the notch there are creating more of an issue. So base bend has that intersection. Flat pattern can't quite calculate it. So that's a problem. And that being the case, let's see how much it's going to take to take the 8 millimeter and put it inside of the fold. Alright, so that shows it as a deformation, which that would probably be fairly accurate. So let's see, edit the sketch. We're 10 millimeters, we're 8 millimeters off the end. It's still in place. And now when we go to flatten, it's able to calculate it because it'll see those as a cylinder. And as it goes through the bend, it very likely will deform that way. So something to keep in mind as far as where that location is going to end up. Alright, so the flat pattern does one thing for us, and under the configurations tab we have the default. When we go over into the drawing, we'll select an A flat pattern view and it'll create a subconfiguration for us. And that's kind of handy for being able to switch back and forth between the group. Alright, so the next in our sheet metal is also in metric. And let's fly that in. And pretty much all inside bins, radius of 5, material thickness 5, and the angle. Alright, the one item of interest is that this angle does have that issue of being parallel to the base, which from a manufacturing process, whatever that's locating, I don't know that it's it's going to be that critical, but we would have to make that, we'll have to make that decision. Alright, so back into the part metric, we'll stay with the front plane, pick our starting point up at a little bit of an angle, down at a little bit more of an angle, and that'll give me enough to get started. Alright, so the internal shapes go 40 on the length, and then these are to the virtual sharps, so would be 50, and then distance of 20. Alright, and then 20 brings it down, and we have a total of 83. So we'll see what that looks like. Alright, so that kind of kicks it over and sets our distance. And just double check real quick. Going into sheet metal then, base flange tab, direction will be 40 millimeters. Doesn't really matter front to back, 5 millimeters and 5 millimeters. And we'll stay with that K factor. Oh, hit tab, not caps lock. And 0.3, there are no tears. And well, 5 millimeters pretty much does away with that sharp. So we're not quite on the geometry. So inside bend radius of 5 millimeters. So what am I telling it to do here? Oh, well, that would help. Let's reverse the direction since it intended it to go up. That looks a little bit better. Alright. So a quick double check, and we'll go with our geometry. Alright, so the two places, we'll open up the, well, let's do that as the whole wizard. And we have still the 8 millimeters. And up to next, double check, yep, 8 millimeters. And 12 millimeters off of the edge. $12 and 16 millimeters. And let's go ahead and set those vertical. So escape a few times to get out of the dimension tool. Make sure they're vertical. Back into the dimension. 16. Go ahead and accept. And we'll see what these look like. Alright, so it gave us 12 off of the end. So that means that those will pretty much be into the bend. So in this case, the thin feature, I think we had better luck with the thin. But we can check 5 millimeters, 5 millimeters. So it's almost as if the 20 millimeters should be off of that face, but we're going to go with what we're given. And that being the case, we're probably going to end up with the deformed hole again. So let's go with an unfold. We'll keep the fixed face. It could go this way and just stretch it out, but let's just collect everything on the bends, flatten it out, go into the whole wizard. And actually that would have let us put all of them into one, but don't know what kind of issues we're going to run into with this dimensioning. Alright, so 12. 16 and distance off of the end, also 12. So it puts it right at the bend. Alright, so we need to fold this back up, collect all bends, bring it back up. We see the deformation across that bend. That should be a kind of the design red flag of, are we sure we want to go through that bend, or do I need to stretch or shrink something to match? Alright, so the other fun number is that we're 14 millimeters off of the flat, and so we need a distance to start with. So now I've done this a couple of different ways. Let's go with the sketch, and we'll come up the 14 millimeters from the edge and then over to the face. Give that a dimension. And pretty much that's just going to locate for that geometry. I want to see what this is going to look like because we need to flatten it and tell it to go that way, but the dimensions, the radius and the 12, are both in relation to this face. Oh, let's see, did we end up with 30 degrees? That may be where the issue is coming in at. So one of our dimensions is going to have to give because this went fully defined. Alright, so 131, we should be at 120. So let's go back to the base flange. 20, 20, and 20. So since this edge is kind of having the issue, or we always kind of have the issue with that dimension, I'm going to turn that over to being driven. And then on the smart dimension, we'll go with, let's see, I want to actually put that 30 degree dimension, so we'll go with the endpoint, get the extension line, and go to 30 degrees. Alright, so that stretched it out quite a bit. May not have even had to unfold it at that point. Alright, so that comes out to be 21.99, and let's see, get that 29.44. So there again, there's a inspection or verify this dimension for the 20 millimeters that we're close, but one of them's got to give, and that looks a little bit better than what we had before. Alright, so once this gets into the assembly or whatever we're going to do with it, then we can make some additional decisions. Alright, so sketch. Place the dimension, we'll make those coincident. 12 millimeters tall by 19 millimeters in. And we'll make that construction, go back, pick up our tangent arc, and do the full radius. So then the way it shows this line is features extrude cut, and the direction of the cut will be along that edge, normal to, and optimize geometry. So just because we can get it in there, oh, that was the normal to. Just because we can get it in doesn't mean that it's going to make it clean or make it manufacturable. Oh, interesting. It stopped a little bit short. All right. So instead of length to thickness, let's just go up to next. All right. So if I go to flat pattern on this one, it shows it in relation to, and we can kind of see the issue with our part is that those angles have to be cut in that direction or in relation to that angle. All right, well, that made the cut clean, but still doesn't necessarily mean that's what I wanted. All right, so I'm going to hide the layout, and we'll save. And this goes to P3-40. All right, so picking up, hopefully all of this works now after going through everything for the Simple A landscape. We're going to pick up the 339. In the list, there's going to be an A flat pattern. All right, so I'm going to put that flat pattern in first, and that's going to create the default sheet metal flat pattern configuration. All right, and then let's see what I did with, are these going to be in dims? All right, so the notes show up. Let's make them dims. And don't really like the way that laid out, so we're going to select all of those, jump over to the arrows, and let them pick up the edges. Okay, so it really wants to be there. Okay, so that gives us the geometry. I can set my dimensions. And there's something still going on with the colors, so I have to go back and see what I set inside of the options told it to do. So let's see how that works with the whole call out, if it'll pick up. It picks up 2 and then it picks up the other 2. Okay, and since this is getting kind of busy, we'll go ahead and set the rest of the dimensions. Okay, so I'm jumping over that. Make sure I'm getting my center marks. And I'll make sure that those good. And let's pick one of these, radius 0.12. And I keep forgetting about the box when it shows up. So let's put a typical. So I'll have those basic dimensions in. And see where we can put those in. So since these are duplicates, maybe they come in 2 times and 2 times. Okay, so there's a little bit of cleanup to do. Still got to figure out why my dimensions are showing up in black when I set the dims layer to blue, so I've overridden something. As far as the bin lines then, we do need to give it location. So if we're going to come off of those different sizes, we can pick up the geometry. Alright, so got a little busier than I wanted it. So let's kind of stretch that out just a little further or find a better spot for it. Okay, so not perfect, but we're on our way. And I haven't applied any of the details. And this is going to bring up another issue with the configuration specific. Let's go back in Model View. We'll pick up 339. Show the bent piece. Let's see what the view palette shows up with. 339. So let's go to front, and then we'll go right into projected and just bring off the other sides. Okay, so the bent, for reference, bring our sizes in. And have it pretty much set up. Okay, so back over on 339. One thing to keep in mind is that, where did it go? Alright, so we now have this default sheet metal flat pattern that when I come in, because I set most of these to be in configuration specific, we're going to have the same part numbers. If we were going to manage these as 339 and part name is that we're going to have two places to enter this data at. And let's stay with the A36. Alright, so when I come over and I double click on the sheet metal and we go back into that custom properties, and then maybe this one picks up the sheet metal designator. So there's a flat part that we could accumulate, and then there's the bent part. Alright, so we got to decide on how we're going to manage. Okay, material was a common, or at least it carried over, and then raw none, apply, come back to the default, go back in, manual, finish could be powder coat, and apply. Okay, so what that should do for us, if everything's working on our template, sheet 1 has the 339 sheet metal layout with the material. Still got to work on that interference with the logo. This one picks up the 0339. Alright, so kind of the importance of figuring out how we want to manage that data and have it transfer over to the parts. Alright, so let's see what this one looks like. Bring in 340, need to rename that. One of the things being careful with the renaming is that before this is attached, I don't have near the issue that we would have after it's in the drawing and the references and the links. So I'm going to jump over to Windows Explorer here real quick. Find my document. Let's see. Shrink this down a little bit. Go into Chapter 3, and this is not the preferred method. All right. If there are any external links, then I'm going to lose those, or it's not going to be able to manage them as well. On the installation, I'm not sure about the education, but there is a program called SolidWorks Explorer that is kind of part of our interface. We expand out, and it's going to find the drive. Okay, so Dropbox 266, Chapter 3, there's all of the files. We can go through and preview. And one of the things that if I had put in the information for all of these, then I would be able to locate it. When I tell it to rename, it's going to look for everywhere that this is used. And we can also include virtual components in the assemblies, which we haven't gotten to yet. So since there's no far-reaching implications, go ahead and hit OK. To a certain extent, this is not the last word on the assemblies. It's a tool, but it's not a perfect tool. So we'll walk that out of the way. I'll browse back. Now I have the rename part. Want to do the same thing. We're going to go pick up the flat pattern first, set it in position, and then pretty much I'm looking at that. I really want to check that, so under the view layout, let's go with a projected view. And it's showing it in position, so we'll go with it. Right, because it's easy to lose that frame of reference. And again, if this angle really has to be there, then we're going to need to manage it. All right. I would argue in the design or in the 112/31 by 60. All right. Well, that's an interesting number. And since it's overbent so much, we need to make sure we have enough ductility in the material to take the bend without cracking. So I'll turn on the arrows, and that arrow went a little bit long, so that tells me that I probably should just go ahead and yeah, that's not much matter which side I went. How about Control B? No. Okay, that side looks a little better now, so it didn't completely get lost. Alright, so dimension to the bend line will stay pretty much on the references. Still have to do something with that dimensionally, but we'll get it there. And then coming off of the other side, right, mainly because these bends are going to kind of work opposite of each other. I'm only going to be able to take a measurement off of that side and then bring this in with that geometry. Okay, so we'll move that up. And then see if we have enough room. We're going to run into the same issue. Is either I'm always going to have a sheet metal drawing and a bent up after the fact, because right now I didn't put any of that information in. So view layout, we'll pick up, we'll go ahead and pick up 339, tell it to refresh. Oh, 340. Oh, since it's not open, we're back into, I could have just browsed from there. Old habits. 340. And we're going to go with the multiple views. So side and top. Pick up our auxiliary view for the end face. And again, I think just out of habit, we'll go into the alignment, break the alignment, move it over. Based on that angle, well, that was a weird angle anyway, so I think we'll leave those on center. Should be able to pick up our dimensions from the edges though, keep it aligned. Okay, have the same type of effect. Alright, so on the sketch, the dimensioned part was originally to virtual sharps. So we're going to create those virtual sharps by picking an edge and going to the point. And based on what we've told, the options for virtual sharps is what we'll get on this geometry. So inside to inside, virtual sharp. And then smart dimension will go from edge to virtual sharp to virtual sharp. Make sure that we stay close. And then from edge to virtual sharp, and we still have to figure out what's going on with that 20 millimeters. Alright, so a few dimensions, still have some more to do with it, but that'll get us far enough along into the sheet metal discussion.